down here. Namely, if we look at the graph y equals hyperbolic cosine x, observe that whereas the function is single valued, it is not one-to-one. In fact, there is a zero derivative at this point here, which leads us to believe that maybe what we should have done was to have broken this curve down into the union of two one-to-one functions. Let me call this curve y equals c1 of x, and let me call this branch here y equals c2 of x. Notice that both c1 of x and c2 of x are one-to-one functions. In fact, let's write this more formally. Using the picture as a guide, let's do the following analytically. Let's say this: define c sub 1 of x to be cosh x, provided that x is at least as big as 0. Again, I mentioned this with the circular functions. Let me reinforce this again. To define a function, it's not enough to tell the rule. You must also tell the domain. Notice that c1 is not the same as cosh, because the domain of cosh is all real numbers. The domain of c1 is just the non-negative reals. At any rate, I define c1 to be cosh x, where x is at least as big as 0. I define c2 of x to be cosh x, where x is no bigger than 0. In other words, these two functions are different because even though the functional relations are the same, the domains are different. The interesting point is what? That cosh x is the union of c1 and c2. But the important point is that both c1 and c2 are one-to-one, and because they're one-to-one, their inverses exist. In other words, I can talk meaningfully about c1 inverse and c2 inverse. In fact, pictorially, what I have is this. See, if I take the curve y equals cosh x and reflect it about the 45-degree line, this is the curve that I get. You see, it's a double-valued curve. All I'm saying is, look at, if we look at y equals c1x, which is a one-to-one function, its inverse is c1 inverse x, which is this piece over here. And if, on the other hand, we look at y equals c2x, that's this branch over here, its inverse is this. You see, notice that these two pieces are symmetric with respect to the line y equals x, and these two pieces are symmetric with respect to the line y equals x. As long as we break this down into the union of two pieces, we can talk about inverse functions. Now, you see, the interesting point is that what most authors traditionally refer to as the inverse hyperbolic cosine of x is really what we call c1 inverse of x. In other words, the definition y equals inverse hyperbolic cosine x is x equals cosh y, and this is very important, and y is at least as big as 0. In other words, notice that the domain of cosh inverse x is really x has to be at least as big as 1. But that's not the important point here. What I do want you to see over here is that when you put this restriction on, is that if you left this restriction out, there would be no inverse function here. I'll come back to that in a moment.